All right, guys, excuse me, we're going to start Unit 11, talking about solid geometry. Our objectives are to classify three-dimensional figures according to their properties, use nets and cross-sections to analyze three-dimensional figures. Okay, three-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face. So when you have this rectangular prism, it could look like a cube, not telling you it's a cube because you can't prove that here, but each side is a face. An edge is the segment that is the intersection of the two faces. Okay? So we have a face here and we have a face here. Here's an edge. Here's an edge between these two faces. Here's an edge between these two faces. Here's an edge between the side face and the bottom face. A vertex is the point that is the intersection of three or more faces. Three or more faces. Vertex, 1, 2, bottom face. Vertex, 1 side, bottom face. All these corners are called vertexes. Okay? So how many faces do we have here on this three-dimensional shape? We have top, bottom, left, right, side, front, and back. So there's 6. How many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. Okay, three-dimensional figures. A prism is where you have two congruent parallel bases. The bases on this prism are triangles. The polygon faces are called bases connected by faces. Okay, let's back up. The two parallel bases are your triangles here. All right? Your other faces are your lateral faces. Those are the sides, and those are rectangles. Then we have a three-dimensional shape that has the bases, two parallel circles. You would not call that a circular prism. You would call that a cylinder. And if you were to cut the lateral face and lay it out flat like a two-dimensional shape, it would look like a rectangle. When you have a pyramid, you have one base that is parallel to a vertex, a point, a common vertex, okay? So this would be called, you name the three-dimensional shape by the base. So this would be a triangular pyramid, triangular prism, cylinder. And then when you have one base that is a circle and a vertex, that is called a cone. All right, a cube is a prism with 6 square faces. Other prisms and pyramids are named for the shape of their bases, and I've kind of already told you that. So you can quickly go over this. You have 2 triangles, 3 rectangles, so that is a triangular prism because your 2 triangles are your parallel bases. You have, let's see, 1, 2, 3, 4, 5, 6 rectangles here. So your 2 rectangles are your parallel bases, so that's a rectangular prism. You have 2 pentagons and then 5 rectangles, so this is a pentagonal prism. You have 2 hexagons and then you have 6 rectangles, so that's a hexagonal prism. You know the base is the hexagons because your rectangular prisms, they're not parallel, they're intersecting. And then on the pyramid, you name them by the base. You have a triangle and a vertex, triangular pyramid. You have a rectangle and a vertex, rectangular pyramid. You have a pentagon, pentagonal pyramid, and a hexagon, hexagonal pyramid. Also on a pyramid, your lateral faces, if you know, are triangles. On a prism, your lateral faces are all rectangles. Okay, we need to classify the figure, name the vertices, the edges, and the bases. Okay, we can say this is a rectangular prism. I really can't classify it as a cube, doesn't give, even though it looks like a cube, so let's call it a rectangular prism. Okay, we need to name the vertices. Your vertices are your points where you have three faces that intersect. So we have A, B, C, D, E, F, G, H. Then we need to identify our edges. And our edges are segments where three faces intersect. So we have AB, BC, CD, DA. Okay, we also have AE, EF, or EH, HD. We already have AD, same as DA. So let's go AE, EH, and HD. Okay, let's look on this side. We already have DH. We need HG and GC, and we already have CD. HG and GC. And let's go to the back side. We have CG. We have CB. Do we have BF? No. And do we have FG? No. And we're missing one. Let's see. So we've got BF, BC, CG, FG. Okay, let's go to this side here then. We have AB, BF. Do we have FE? We don't have FE. That's the one we're missing, last side there. All right, and now we need to label, let's see, the bases. Okay, so let's label the perpendicular bases first. So we have A, B, C, D, and E, F, G, H. Okay, then we can label front and back. So A, D, H, E. And the back would be B, F, G, C. And then we got our left and right side. A, B, F, E. And our right side, H, D, C, G. Now, do your letters have to be in the same order as mine? No, but remember, on the A, B, C, D, you can't go A, B, D, C. You need to be consistent here. You can go A, D, C, D, or you can start with a different vertex. All right, that's it for number one. Okay, classify the figure. We have one base and we have a vertex, so it's some type of pyramid. You name the pyramid by the base. That's a five-sided base, so that's a pentagonal pyramid. Name the vertices. The vertices is where you have at least three faces that intersect, so it's A, B, C, D, E. Name the edges. So you have A, B, B, C, C, D, D, E, E, A. And then you have A, F, B, F, C, F, D, F, and E, F. And then for your base is the hexagonal prism. or a pyramid. That's not a prism, that's a pyramid, because you have one base and a vertex. Okay, classify the figure, name the vertices, edges, and bases. You all can't really see this in your diagram, so go ahead and add that. In the middle of this cone is a vertex with a point M. Okay, so you have one base and a vertex, so that is a cone. Your vertice is point N. You have no edges on this cone. And your base is, would be this circle right here. Circle M. Okay, a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form three-dimensional figures. To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. So let's look at some of these. All right, describe a three-dimensional figure that can be made from the given net. Now, you all should know this. If you fold this net up, you're going to have what? You're going to have a rectangular prism. Okay, but how do we know that? Well, a rectangular prism has two parallel bases and three or four rectangle sides. Well, all of them are rectangles, so you know it's some type of, saying it's a cube. I'll also take a rectangular prism for this, but you know it's some type of prism because of the rectangles. I always want you all to prove whether it's a cube or not, and it's not telling you the sides are congruent or that, well, you know you've got four right angles because of your perpendicular lines here. So I will accept cube or rectangular prism on that one. Okay, what about this one? Okay, for a prism we need rectangular faces and we need triangular faces. Well, we have neither here. We have one circle and we have a hemisphere, which is half of a circle. So if you can remember, when you have the base of one circle and a vertex, this is a cone. Okay, we have no rectangular faces on this, so this has to be some type of pyramid. All right, we've got all triangles, so you would call it a triangular pyramid. Cross-section is the intersection of a three-dimensional figure and a plane. Okay, so we have a three-dimensional figure here, which is a cone, and then we have this, looks like a parallelogram. Where do they intersect? They intersect at the red point. Okay, so the cross-section here is a point between the intersection of these two figures. All right, so now we have, let's see, we've got a pentagonal pyramid, and we have a polygon again. So this polygon is cutting this pyramid right here. And if you notice, this is where they intersect. So what type of two-dimensional shape is that? That's a pentagon. So the cross-section is a pentagon. And then our last one here, if you can see this, we have a circle. And we have a vertex, so this is a cone. And then we have this quadrilateral here intersecting this cone. So can you see where the intersection is? The intersection is right here. So it intersects in a triangle. Kind of cutting that cone in half, and where they intersect it would be a triangle. That's called the cross-section. And that's it, guys. That's it for 11-1. Have a good one.